Yes, so hello everyone. My name is Christian Klein. I'm a senior cloud architect at Elastisys and a researcher at University, both located in Sweden. And I'm passionate about cloud computing and also information security. And Elastisys, as a senior cloud architect, I'm kind of working on marrying the two in our flagship product that we call Compliant Kubernetes, and whose aim is basically to simplify compliance with GDPR, but a bit like in the previous presentation, without sacrificing the developer velocity. So we already mentioned a little bit privacy shield at the very beginning of the RegOps Days. I'm going to very briefly talk about what is GDPR and what is Privacy Shield, what's their current status, and what's their implication for EU business, especially those that do want to use cloud technologies. And then I will present what are cloud native technologies and how they can help address GDPR compliance. So let me start with GDPR and Privacy Shield. So first of all, GDPR is, or General Data Protection Regulation, is an EU law. Okay, so this is different. You have European directives, which still need a national law created accordingly, whereas GDPR is a regulation, which means that it's basically national law directly in each of the member countries. And it applies to the European Union, but also to the European Economic Area. And since I assume your question is pretty high up of your mind, what happens to the UK? Well, it seems like they have just taken a legislation which they call the UK GDPR, which basically is copy-paste of GDPR, and they change the name of the institutions to the ones that are applying to Great Britain. But otherwise, it's pretty much the same version of the law. And GDPR also regulates data transfer of personal data outside the European Union and the EEA, so the European Economic Area. Now, let's start with what exactly is personal data. And GDPR defines personal data as any kind of information that can directly or indirectly identify a natural person. So now the typical things that somebody would think of is the name, their social security number, their address, their home address, their location, and so on. However, notice the subtlety of the law that everything that allows you to indirectly identify a natural person also count as personal data. So, for example, online identifiers such as cookies and IP addresses can be used to indirectly identify a natural person. And in fact, the European Court of Justice has ruled that IP addresses are personal data, and so you need to be careful in the way you're collecting and processing them. So very importantly, the definition is rather open, which means that data that perhaps today doesn't feel like it's personal might become in the future personal if somebody figures out that, well, there is a way to indirectly identify an individual based on certain information. So at any rate, if you process any information that may directly or indirectly identify a natural person, then you need to comply with GDPR. And GDPR introduces some terminology. The most important ones are data subject. So this is any natural person or individual who can be identified directly or indirectly, as I said before. Data controller is the entity that determines the purpose and means of the processing. However, it might be that the person that determines this processing and the person that actually does the processing are different. So then GDPR also introduced a term called data processor, who is actually processing personal data on behalf of the data controller. Now, one should also be aware of so-called data sub-processors. So entities that process data on behalf of the data processor and to whom the legal requirements of GDPR are also usually transmitted via some like data processing agreements and so on. So GDPR brings quite a few requirements on the data processor. For example, you need to have a legal basis. There are 6 reasons why you're allowed to collect personal data, consent being just one of them. And if you do not have a legal basis for personal data collection, then basically your data collection is illegal. Another example of what GDPR requires you is data minimization. So you're just supposed to collect the minimum amount of personal data you need for the specific purpose. So if the user, for example, gave you consent to collect their name, then it's not okay for you to also ask for their shoe size or also process other information that they didn't give an explicit consent for. Yeah, so for example, let's say that you collect personal data to comply with some contractual obligation, right? Somebody signed a loan agreement and you need their address in order to figure out to whom to send the contract. Like I said, you're not allowed to ask for more information that is strictly necessary to fulfill that particular contract. Now, an interesting implication of GDPR is that you cannot really talk about privacy without first having a solid information security foundation, right? I mean, if your organization is keeping data privately and is treating it with respect and so on, but that data leaks outside its control to some bad actors, then of course, basically privacy cannot exist. And it really saddens me. For example, I understood that Finland was a medical center in Finland was recently under a ransom attack, and basically the data of the patients was kept hostage, and in order to ask for money. Basically, yeah, they were threatening to release that data without the patient's desire. So that is a very sad event, and it really sickens me. But on the other hand, it also shows how important information security is in order to ensure privacy. And in fact, GDPR goes one step further. So it has explicit article that says you are supposed to have data protection by design and by default. And furthermore, you have to monitor and notify breaches. So you cannot just, in the United States, for example, it's often the case that at least half a decade ago, it was the case that, well, a breach happened and then nobody was talking about it because some kind of acquisition was happening. Whereas with GDPR, you explicitly have to inform your data subjects and also the data protection authorities if you detect a data breach. So how is GDPR enforced? Well, each European country has a data protection authority, which may impose fines of 4% of your total global revenue, or 20 million euros, whichever is greater. And there is even a website which is there to blame and shame. So otherwise put to raise awareness of all the fines that are being given. And I have extracted here a screenshot with the top 5 fines that were applied as of today. And as you can see in the rightmost column, so the reason why the fine was applied, you can see that fines are not only imposed for insufficient legal basis. So again, you collected data without having a good reason for doing that, but also due to failure to take adequate technical and organizational measures for protecting personal data. Now, the organizations that are here feel big, right? So sometimes smaller organizations feel like, yeah, GDPR currently just fines the big organizations, so this is not really something I need to worry about. But interestingly, so Merit, for example, the 5th in this screenshot, they were actually fined because they acquired a smaller company, and then that smaller company didn't properly comply with GDPR. But since the violation was only discovered after the merger, then basically Merit got fined. So what really I'm trying to say here is that even if you're a smaller company, if you do care about merger and acquisition, or you do care about being sub-processed to a larger company, you really have to take GDPR seriously. Now, GDPR applies only within EU, so specific to businesses operating in EU or processing personal data of EU citizens. However, privacy really feels like an international trend. So there are extremely many countries that have taken the GDPR model and implemented similar laws. And so having a good GDPR posture already from now may reduce your compliance burden when expanding in several other markets. Now, probably you're asking me, what about the US? Well, the US is, as somebody characterized it, a messy landscape. So there is a patchwork of legislation covering privacy in very specific industries, in very specific cases, or at the state level. So for example, California has recently passed the California Consumer Privacy Act, which is pretty much similar to GDPR. However, it only applies at state level and not at federal level. And this is, of course, a very big problem when transferring data from the EU to the US, because when transferring data to outside the EU, you need to make sure that the laws of that particular country are allowing you to sufficiently protect the personal data of your data subject as if you had that data in the EU. Now, until this summer, there was Privacy Shield, on which very many companies were relying for legally transferring data across the Atlantic. However, this was challenged during the summer, and basically the European Court of Justice ruled that Privacy Shield can no longer be upheld. And it's quite an interesting read to see why exactly they reasoned about this. Suffice to say that basically boils down to different culture around data privacy. In the US, the state needs access to personal data in order to protect its citizens, whereas the EU sees it as a human right to be allowed to, have your privacy. So why is this important? Well, as a data controller, you are responsible that your data processors are GDPR compliant. And this includes also your sub-processors. And for example, if you're using, right now around 60% of the public cloud market is being dominated by AWS, Google, and Azure, and stores quite a lot of the European startups and other companies. So that, and again, it's legal jurisdiction that matters and not the physical location of data center. So currently there is a huge legal uncertainty on whether it's currently okay, or maybe it will be in the future okay, to legally use US-based cloud providers. Now, okay, so what can you do about it? Well, first of all, the European Court of Justice was very close to ban so-called standard contractual clauses or corporate binding rules, but they said that, well, that still applies as a mechanism for cross-Atlantic data transfer. However, it's your responsibility to determine whether that kind of transfer is okay and whether the laws of the country in which you're transferring allow you to protect the personal data of citizens. So there are other choices that you have, such as encrypt the personal data when you're sending it to a public cloud provider, but that also makes the public cloud provider a bit less useful. You could ask for explicit consent from your users to transfer it to the US, but that might be a little bit tricky. And what 10% of the respondents said that they would be doing is to simply aim for more EU cloud providers for personal data processing and be less reliant on US-based cloud providers. So the good news is that you have quite a lot of options in the EU for public cloud providers. The bad option is that they generally have a lot fewer services than the big American cloud providers. So AWS, for example, has some like 210 services, whereas a typical European cloud provider has maybe some like 5 to 10 services, which are generally focused on something like infrastructure and storage, so very, very low level. But of course, there is a renewed focus on data sovereignty, which maybe might bring the European landscape on par with the US-based cloud landscape. So you as a EU business, in order to comply with GDPR, yeah, you would kind of have to build a platform. But the question is, okay, how can you still comply with GDPR and use European cloud providers, but without having to build a platform from scratch? And this is where Kubernetes and cloud-native computing technologies come into the picture. So let me talk now about Kubernetes and the cloud-native ecosystem and how they can help you with GDPR compliance. So first of all, just to make sure that I set the expectations correctly of my talk, when talking about any kind of compliance, but in particular GDPR compliance, it really has several levels. So you have to have the right policies in place in your organization. You need to have the right processes. You need to make sure that your employees are trained on what it means to be private and how to handle users' data with privacy in mind. Then you have your application, where there are also very many GDPR-related requirements and where you need to put some functionality. And then comes your compliant platform, right? So the platform on top of which you're building your application. Now, we have already seen that we're having quite a large choice of compliant cloud providers in the EU. So the rest of my talk is really going to focus on how can you have this compliant platform. And like I said, you can either build this platform yourself, but that's not probably where you want to put all of your effort, or you can use battle-tested, community-maintained open source projects in order to build this platform. And this is where the cloud-native ecosystem comes into play. Let me read out the cloud-native definition. So cloud-native technologies empower organizations to build and run scalable applications in modern dynamic environments, such as public, private, and hybrid clouds. These techniques enable loosely coupled systems that are resilient, manageable, and observable. Combined with robust automation, they allow engineers to make high-impact changes frequently and predictably with minimum toil. So I have highlighted a few keywords in this definition. Let me first start by highlighting the fact that cloud native does not mean that you need to use Amazon or Azure or whatnot. Rather, it empowers you to run your application both on public cloud providers and also on your own servers in the basement. That's what private clouds means in this context. And secondly, the end goal is really to speed up your developments, to allow them to make high impact changes frequently, but with minimum effort and the minimum downtime. Now, at the heart of the cloud native ecosystem is the Cloud Native Foundation, or short CNCF, which is also part of the Linux Foundation. They act as a nest for a blossoming ecosystem of open source projects on various topics, such as container orchestration, databases, message queue, or storage. There are currently over 1,000 projects, and the CNCF actively reviews them, either by proposing some end user surveys, so people that actually use these projects, they are being questioned, okay, how did you feel about it? How easy was it to use? How good was the documentation? But also by doing their own evaluation on the technical and organizational maturity of these projects. So they have certain objective criteria, for example, that there needs to be at least this many organizations that actively participate in the governance of these projects to make them a vendor neutral, and not to make them a vendor lock-in target. And of course, the most prominent and first CNCF project is Kubernetes that, well, if you're working in the cloud area, you might have heard of them. And all in all, Cloud Native and Kubernetes really allow you to achieve cloud agnostic compliance. So this allows you to build your application on top of a platform that can run seamlessly both under US and EU jurisdiction, and furthermore, avoid vendor lock-in. So here I'm giving a rather long table of what it would mean to move away from, let's say, AWS. So for example, if you want to run your code as containers, in AWS, you might do this via a service called EC2 or ECS or Fargate and so on. And then if you want to move away from that, you can use Kubernetes. In fact, the Kubernetes project is has become kind of a standard for hosting all of the other projects that I will mention in this slide. Now, if you, for example, prefer to run your code as under the serverless paradigm, so AWS Lambda might be the service that you have heard of, there is the Knative projects that will help you do that, but in an AWS neutral way. So for briefness, I'm not going to go through all of these services in list, but I just really want to highlight that pretty much there is a CNCF project for all of the major cloud services out there. Now, of course, the devil is in the details. Just because you're using cloud native technologies on top of a European cloud provider doesn't automatically mean that you're GDPR compliant. So in the time remaining, I will discuss some subtle technical challenges when implementing GDPR with cloud native technologies. We have, in fact, looked at some GDPR articles and looked at the more technical one of them, and found the following list that has implications on how you would configure and implement a Kubernetes based on a cloud native based computing platform. In what follows, I will focus now on Article 25, and that is about data protection, and then Article 33 and 34 that are about breach notification. So Article 25 means data protection by design and by default. And here is where I'm going to get a little bit more technical, just to make sure that everybody, people familiar with Kubernetes have something out of this presentation too. So if you recall, often when you're creating a Kubernetes cluster, you have one single set of credentials, and that's kind of being shared with all of the developers. And that's not okay from an information security and data protection point of view, because then you cannot really track who did what inside your application platform and how potentially that application platform was tampered with. So the first thing is to add proper authentication so that you're identifying the individuals that have interacted or have configured or changed the platform. And this can be achieved, for example, with the project called Dex. and afterwards you just connect it to an OpenID Connect provider, so something like Active Directory, or if you're using Okta for identity providers, or some people have, or even using the G Suite in order to provide a username and password to each of their employees. So if you're already doing that, you can just use the DEX project and also comply with onboarding and offboarding requirements also when revoking and giving access to Kubernetes clusters. Now, Kubernetes already comes with very powerful role-based access controls, which basically means that each of your developers can be given just the right amount of access they need in order to officially fulfill their task. If you, however, needs even finer control, then there is a project called Gatekeeper that basically allows you to specify policy as code. So for example, let's say that you have an internal policy that says we always want to have 2 copies of the application running, so that in case one of them fails, that the application is still going up. Well, you can actually implement the gatekeeper rule to say, well, replication needs to be equal to 2. If this doesn't happen, or if somebody tries to change this, the request will just fail, and this way you avoid compliance violations. Now, the last thing is also, it's very important to have logging. So to understand who did what, in order to be able to create a feeling of accountability in your organization, but also to just be able to identify suspicious activity or things that are not quite okay. And here, when dealing with GDPR, you have to be rather careful. Logging tends to include also personal data because, yeah, it's just the way developers work, and they often need this information for ensuring that the application works correctly. So there you have to be very careful about configuring the right retention time. So currently, for example, you might be setting something like a 30 days retention time, after which the logs are being thrown out. And this ensures that you're complying with the requirement of data minimization, not keeping personal data more than necessary. Now, also part of data protection and by design and by default is to add several layers of security. So for example, you may configure a so-called pod security policy, as I have illustrated some code on the right, which basically further locks down what your application can do on top of the platform. So role-based access controls and policy control says what the developers can do against the platform, and then pod security policies determines what your application can do on top of the platform. So this really allows you to add yet another layer of security, so that if, for example, there is a, let's say, Linux kernel vulnerability, you don't have to scramble to immediately wake up somebody at 2 a.m. in order to, upgrade clusters, but rather you can take that within a short notice, within 7 days or whatever your policy state. And finally, you need to encrypt data when between the end user and between your application. This is just good practice. And there is a project called Cert Manager that automatically deals with issuing TLS certificates and renewing them on your behalf. Let me now talk a bit about GDPR Article 33 and 34. So these are basically both related to the fact that you need to notify your data subjects and your data supervision authority in case you detect a breach. But this, of course, also implies that, well, you need to have some kind of mechanism to detect the breaches. And there is a CNCF project, Falco, that is basically looking at low-level, if you're familiar with the term system calls that your application performs, and looks at suspicious activity and then issues alerts based on that. So for example, if an application tries to, let's say, write to a file which is not supposed to, that generally suggests that something is not quite right. Maybe there's an attacker that is trying things out to penetrate in your infrastructure. So then you definitely need to have some alerts. And then also a little bit as a forensic thought, like as an afterthought, you can then track the steps that your attacker has made and evaluate the impact on personal data breach, so as to know what to communicate to your data subjects and to your data authority. Now, of course, in order for this to work, again, you need to make sure that logging is enabled, and you need to make sure that whatever this tool produces is being shipped to a tamper-proof logging environment. Otherwise, the attacker will very likely try to hide their steps by just erasing the logs out of that environment. And on the right, I'm showing here a little bit of a piece of code that enables something called Kubernetes audit logs. So this basically allows you to track all activity that, all requests that have happened against Kubernetes and all the other projects to see who did what change. So I hope I convinced you that on one hand, cloud-native technologies offer an opportunity for reducing compliance burden with GDPR. However, the devil is in the details. And in order to reduce this compliance burden and allow people to focus on what they do best, application development, Elastisys develops compliant Kubernetes, which deals with many of these issues and many more, such as capacity management. How do I check that I don't run out of disk unexpectedly and my application goes down? Or network segregation, like making sure that my database is well protected from the internet and things like that, so that it makes an attack and leakage of personal data even less likely. Or vulnerability management, to make sure that I don't have vulnerabilities and known attack vectors in my production environment to begin with. And yeah, I don't really have time to go through all of these, but let me just say that we have identified the best open source project for each of these questions, and we also have the knowledge to configure it appropriately. And compliant Kubernetes is available as open source. You're free to operate it yourself in any combination of on-premises or public clouds. And we even encourage you to contribute back to it in case you feel that it's missing something or something can be improved. However, if you want to keep your in-house resources focused on your core business, then together with our partners, we also offer compliant Kubernetes as a managed service across cloud providers, both in EU and US jurisdiction. So with that, I would like to conclude my talk, and I would like to summarize it by saying that GDPR requires strict handling of personal data, and failure to do so can result in encrypting files. The end of Privacy Shield has raised the barrier for transferring personal data between the EU and the US. Fortunately, cloud-native technologies offer building blocks for building cloud-agnostic GDPR compliance. And let me give another shout out to try out compliant Kubernetes. And if you like it, please star us and even contribute back. Thank you very much for your attention. And I'm ready to take questions now.